Perfect. Okay, so if we are all in, I will start. Uh, Welcome to the session related to the new generation Linux based Barionet from the distributor training 2020 that we are doing virtually and remotely this year. The Barionet is a programmable input-output devices mainly for IoT applications. And in this session, during this presentation, we will analyze what the problem the device is solving, how it is solving these problems. So we will see some of the features and of the capabilities of the device. What market are we addressing with the Barionets? What does the customer need to order and to download? What information about this solution is available and where you can find it? And what are the future plans of the solution of Barionets? I can tell you this upfront, the presentation will be probably a limited presentation. Well, not a limited presentation, but what I will show you and the examples that we will go through are probably limited compared to the fully capabilities of these devices. Because of their nature to be fully programmed, there are so many applications you can do with them, and you will learn more as we move forward. The session will be split into two main parts. This first part being the presentation, going through a PPT, and then we will move to the hands-on training where I will show you some examples of coding and what you can do with the Barionet 400. But let's move forward. So what are the problems we are solving with Barionets? Well, Barionet is perfect for automation and control application. So you can trigger an automatized process by closing a contact closure, for example, and you can have the control over this process as it moves forward. You can monitor, and from the data retrieved from the monitoring, for example, the monitoring of sensors connected to the Barionet devices, you can warn or even send alarm. You can interface Barionet with the two most famous platforms used for emergency mass notifications, which are Informacast from Single Wire and Synapse. These are, especially Informacast, is very well integrated into Cisco environments where it is used with many different IP devices and is able to interface all these IP devices into two main types, being activators and receivers endpoints. And you can trigger notifications with our Barionets, even to third-party systems. Synapse is working behind the same principle, and we will see an example later on. Security access control. Well, Barionets being equipped with different kind of interfaces, you can, for example, connect a smart card reader or a fingerprint reader or whatever device can be used to make sure you are the person that has to open the door. So this is an application for this kind of field and market. You can measure temperatures and do something based on the temperature that you're reading. And we can, you can also do integrated payment solutions. There are some examples made by the partner company of Barix, which is called Kiba, that integrated Barionets into vending machines to automatize the sales process in coffee machines. A good acronym to remember about Barionet is MARTA, which is a common Italian name, not written like this with one less R, and stands for Measure, Access, Record, Report, and Take Action, which is exactly what Barionet allows you to do. So when we talk about Internet of Things, maybe the first thing that comes to your mind is a smart building or smart grids or smart cities, as they are called in these days, where different ecosystems, and you see the ecosystems I'm referring to listed in this picture, have to be remotely managed, controlled, monitored, and users have to take action based on the data that they can retrieve from these ecosystems. We are talking about lighting, elevators, access control again, heating, ventilation, and air conditioning, fire alarm, surveillance, energy control, and meters. One of the coolest features of the new Barionets is that they have native support for the MQTT protocol, which is a lightweight messaging protocol to send tiny pieces of data to remote devices. It works based on a principle of publishers and subscribers passing through a broker. These are the terms used in the MQTT world. And Barionet comes by default with MQTT support. So you can build your own clients, being publishers or subscribers, and you can connect sensors, for example, to publishers. Let's say that I have a temperature sensor and I want to send the reading of the temperature sensor to a dashboard on a web portal, for example, Grafana or Victoria Metrics. And Johannes is very well prepared on this topic, and he will talk about this topic maybe at the end of the session, where you have your customized dashboard and you can read all those data. I spoke about the temperature sensor, but you can also measure voltages of batteries, of power management plants. You can measure voltages of solar panels. You can measure water tank pressure levels. And you can have all these readings in a very nice dashboard on a web portal. And do something on another Barionet that is maybe a subscriber to the same topics published by the sending device. And this Barionet is taking action automatically based on the readings that the broker is sending to that. So this is a brief overview of what MQTT is capable of. But let's move forward. How we are solving these problems. We have 4 different models when it comes to the new generation of Barionet, and we will see the capabilities of each one of those. They all share in common the same CPU, which is the Kino module. They have an embedded Linux based on OpenWRT inside as an operating system. Is now Lede and OpenWRT after they joined together. The device is fully programmable in C++, Lua, or Python by default, and the device comes by default with Lua already installed. So you have Lua and several other packages that allows you to start off writing your scripts and use the device in that way, in that direction. If you want to use Python, sure, you can install Python and do your script with Python as well. We have native support for MQTT, as I said. It has the possibility to use the IPv4 or IPv6 stack. It has 1 Ethernet port, 100 megabit, and it comes on a standard DIN rail case. So you can mount it in your electrical boxes. The Barionet 200 is the smallest of the 4 devices. It has 1 digital input. It supports the possibility to connect to a Wi-Fi network. It has 4 USB host interfaces that you can use in the way you prefer. It has option for PoE, so you can implement PoE capability, but this is optional, so it's not implemented by default. And it has an option for the real-time clock for OEM requests, in case you have. The Barionet 400, it has 4 relay outputs, which are capable of handling 30 volt, 0.5 amps, 4 digital inputs, 1 USB interface. It has support for PoE, so you have just to connect a PoE switch with 1 network cable, and the device is good to go. And it is the first of the 4 models that is supporting SNMP exposed in the web UI, and it has a Synapse client by default installed in the device. The other models can have SNMP support, but you have to program it yourself in this moment. The idea is also to align all the 4 models with the same kind of exposure that we gave to the Barionet 400. And why we added SNMP? Because when you have to interface Barionet with Informacast, you will have to use what Informacast call M2M plugin, which stands for machine to machine, and it operates on the SNMP protocol. Informacast uses SNMP version 1, version 2. Now we are implementing version 1 only in our Barionets. And you can set essentially the server address. You have 2 fields, server 1 and server 2 for redundancy purpose. And then you can trigger traps to be sent when a contact closure is closed. This is how it works, and I will show you also later on the user interface. Synapse, on the other hand, it has a built-in client. So when you switch on your device, it is automatically identified from a Synapse server, and the capabilities of the device are announced to the server, and the server knows that the Barionet 400 has 4 digital inputs and 4 relays that can be controlled. On the Barionet 400, we have an option for the real-time clock for OEM requests again. The Barionet 1000, it has support for Wi-Fi. It has a Wi-Fi chip built in. It has 2 relay outputs, 4 digital inputs, 4 universal inputs. So you have the chance to set them working with analog or digital. You have 4 digital outputs. You have 2 USB host interfaces, and you have the serial RS-232 interface. And it has the Dallas one-wire interface to connect your temperature sensors. The most capable of the 4 models is the Barionet 1100, and I will not spend the words on the first lines, which we already saw them. In addition to what the Barionet 1000 has, it has essentially the RS-232 and RS-485 interfaces. It has a real-time clock with gold cap buffer built in. It has the Dallas one-wire interface, again, for the temperature sensors. It supports Modbus, RTU, or TCP. And it has 2 options, one for the CAN bus interface and the other one for LoRa interfaces, where CAN bus is mainly used for automotive applications. And on the other hand, LoRa stands for long range, and it is this protocol that allows you to have sensors, LoRa compatible sensors, that are far away, up to 10 kilometers, and that are transmitting tiny pieces of data over the wireless, over the air, using radio frequencies in the sub-gigahertz, which changes according to the country where you're using your device and where you purchased the sensor. We have the option to implement this interface in Barionet 1100 too, to complete the Internet of Things protocol suite. How you can access and configure the device. So once it is connected to the network, you have the possibility to access the local Barionet user interface, which is the most basic one. It allows you to configure the basic options. As you see from the screen here, we have the Wi-Fi, the Ethernet, a status panel, and for the Barionet 400 latest release, we have also the SNMP, the Synapse, and advanced is where you can access the second user interface, the second level of user interface, which is Lucy. Lucy is the standard user interface used in OpenWRT routers and systems. So maybe you already jumped into Lucy by using an OpenWRT, a router based on OpenWRT, for example. And in Lucy, you have a very detailed control on the network capabilities of the device, on the security capabilities of the device. You can set the device to operate as an access point or in client mode connecting to a Wi-Fi network. You can set other firewalls features when you're using the device as a router, for example. So you have all these options, plus a Barionet tab that you see there, where you can easily and quickly control, and it's exactly what you're seeing on the screen here. The 4 relays in this case are the ones related to Barionet 400. So you can test your external equipment that is connected to the Barionet quickly and immediately from here. You can also upgrade the firmware from Lucy, but we will see also later that you can do that from the other interface, the Barionet user interface too. Lucy is a part of the OpenWRT project, an open source project, and there is a very large documentation about it. So we will not spend too much words during this session about Lucy. If you are interested in knowing more, please visit openwrt.org. The third level of access that you have is the one that allows you to program and change and tweak the device according to your desires. Is via SSH. Well, you can access the file system. You have root access to the file system in this way. So you can tweak already installed packages, or you can install other packages depending on what you need the device to do. So if, for example, you don't like a package that is installed that is for MQTT, for example, and you want to install another one, you are free to try that out, and you're free to do it from the SSH terminal. You can build your custom applications written in Lua, Python, or C++, as we saw before already. And the concept here is that in this case, the device is 100% user programmable. We are always here to give you support. If you have a project where you think the Barionet can be uh, the, the perfect device for it and it can do the work for you, please don't hesitate to get in touch with us. We can provide you support to write your Lua scripts or other type of programs and to uh, manage to have the device doing what you are asking for. Now let's speak about use cases. So we will see some examples of use cases. In this first configuration, we have the Barionet device connected to temperature sensors up here and to a switchboard here that are maybe controlling an alarm or a door contact. This is just an example, but it can be already a use case where Barionet can be deployed. So the temperature reading overcome a certain level and an alarm is sounded. Easy. Or you have your switchboard that is controlling something like a door, or maybe you want to switch on lights. At the same time, having the possibility to use IoT portals, which MQTT is an example, but there are also other examples. Maybe you have your own IoT portal where you have your own command center already deployed. You can command the Barionet through TCP or UDP interfaces, and you can have the device doing whatever you are sending from the command center placed remotely. Again, the RF interface, this can be a LoRa device connected to a humidity sensor, maybe installed on top of the mountain, and 10 kilometers downhill, you have the command center where Barionets are doing something based on the reading of this sensor placed far away. This is all possible with Barionet. This is an example of an Informacast notification played out on an IP speaker, always from Barix. So you have a contact closure connected to the device, to the Barionet on the input one, which is triggering a broadcast notification started from Informacast single wire via SNMP. So the trap is sent to Informacast, and Informacast can be programmed to send whatever notification is capable of. In this case, an audio notification to IP speaker, but at the same time, maybe you have Cisco phones deployed in your company and they are receiving the same kind of notification. Synapse work behind the same principle, but it doesn't use SNMP. It has its own API to communicate with their endpoints and activator devices. An MQTT protocol visualized, and this is a very easy and a simple example. You have a temperature sensor connected to a Barionet 1100, which is publishing the temperature. The broker, which in this case is an internet remote cloud portal. There are many different brokers online that allows you to create a free account to test your devices or to use your devices, like I am doing. And the broker dispatches the information, the data, to other devices that are subscribed to the same topic. You can create many topics depending on what is the argument that we are treating. In this case is the temperature sensor from the kitchen, maybe. So this is the topic. And the device that is subscribing to temperature sensors from kitchen will receive the reading and it will do something accordingly. In our case, we can connect, for example, an alarm. Or at the same time, you can have the device publishing onto a remote dashboard, like again, Grafana or Victoria Matrix, and you can have a very nice overview on what is going on in terms of temperatures or humidity and other sensors that you can connect to the Barionet devices. Other clients, MQTT clients, can run on smart devices too. So you can, for example, activate a relay remotely from your device to turn on your lamp the lamp is connected to the Barionet, and you can switch on your lamp remotely from a mobile device using MQTT. So just to summarize, we have the possibility to use Barionet for monitoring water pressure and tank levels. This came directly from Johannes' farm. To monitor power generation and power use over Modbus TCP and Modbus RTU. Monitor temperature and automate processes based on the readings. We can control doors, switches, lights. We can send network messages via TCP or UDP to trigger specific events to happen. We can even program events with built-in timer programs like the famous cron. It's in all Linux file systems. And or in this case, the device comes with the Lua socket library built in, and you can use socket.slip to have your, for example, advertisements played every X seconds, depending on how you programmed. And more. This is, as I said at the beginning, this is probably a limitation, what I'm talking about, but it's just to give you an idea of the capabilities of these devices. Now, what markets are we addressing with Barionet? These are the problems that we already saw and that we analyzed a bit. And we think that they might be suitable for industrial applications, residential, in example for domotic, to control and monitor your house remotely, for commercial, where the same principles can be applied. At the beginning, we saw smart buildings. So this is a hot topic nowadays. Transportation, we allow you to have the option for a CAN bus to connect different sensors on a vehicle and to have the control over those sensors. For security and more, again, here we are probably limiting. You might have more ideas than I do, so maybe we can have a discussion at the end of the session. These are the 4 ordering numbers about Barionet. They are coming without PSU. And in case, of course, of Barionet 400, you have the PoE capability. Where can you find information? Well, the first source of information, of course, is our website, where you have descriptions on the device, and you have the datasheets to be downloaded in the download area. Firmware updates are also there available for you. Or you can connect to the help.barix.com, where we are publishing online our quick install guides. There is not yet a user manual, unfortunately, for Barionet, but there is a plan to make it. So soon we will have it. Other information beside the ones mentioned are always available. Contacting us directly, support@barix.com. So feel free to send us an email anytime. External documentation about Lucy and OpenWRT is available on the mentioned site. If you want to learn a bit more about Lua, please visit lua.org. It's very well documented programming language. It's not difficult to learn. I am not a programmer. I don't have a background as a programmer and developer, but I managed to create my own simple scripts that I will show you later on that are already doing some kind of applications in Barionet, and that you are free absolutely to copy and use. And about MQTT, you can have a look at mqtt.org if you are interested to learn more about this fantastic lightweight protocol. What future plans are in place for Barionet? And my call here is also feel free to give us ideas on where the product should go, what features should be implemented, what are your experiences, what are your customers saying about the Barionet devices, especially these new ones, which are not on the market since too much time, are kind of really new devices. So it's important for us to retrieve as much feedback as possible, being a critic, a comment, a suggestion, a recommendation. So the future plans are to add Synapse and SNMP version 3 to enhance the security of the SNMP protocol, which is already included, and align all the Barionets to have this support. The idea is to have one firmware that automatically configures itself based on the Barionet is running onto. Implement HTTPS secure access on all the product line of Barionet. Currently, the secure access, I'm referring to the web user interface secure access, and currently is available only as an option on the Barionet 400. Uh, there is an idea to expose the controls of the built-in interfaces of the Barionet 1100, just like it happened on the Barionet 100 and Barionet 50, where you had all the interfaces controls exposed in the user interface. In this moment, if you want to use those interfaces, you have to go into the, you have to SSH into the product and program it by yourself. And we should add support for the extensions that were used with the previous Barionet devices, the 50 and 100, which are the IO12, X8, and R6. Currently, it should be trivial to add this extension to the Barionet 1100 because it has an RS485 interface. But on other Barionets, the smaller one, it's not yet tested, and an implementation has to be made. We offer development support for scripts. So if you need, again, to write custom scripts for an application that you think could have a project, please write to us, write to me directly if you want, and I will be happy to support you fully. And again, custom projects are always highly welcomed. As you know, Barix is famous for its reactivity, as I understood also in these latest months. And we are always happy to support custom projects. And now, if you don't have any further question, if you don't have any question in this moment, I will move forward and show you the device and its capabilities. We will see an overview on the device. I want to trigger a Synapse notification that is playing on IP speaker 2. I want to trigger the playback of an audio file via UDP on IP speaker. I want to show you an MQTT example. I want to show you how you can log the timestamp to a file when a contact closure is closed. And at the end, we will see a bit of live coding. So we will do a very simple example on how you can access via SSH and run your code directly from the device. Okay, so let me move forward. Feel free to interact anytime, okay? I have to go back to OBS for a second.
So guys, feel free to send some questions. Also, since it is useful for us also to understand if you are sleeping or if you are attending.
Yeah, I hope you're not sleeping.
Our great show, for sure, for sure.
Good. So
go,
here, can you see the camera?
Yes, it's perfect, Davide, go.
Okay, so I have on my desk the Barionet 400, and as you can see, a ceiling speaker where I connected my IP former device. So these are the two tools I will need for these examples, but let's focus on Barionet. This is the Barionet 400. As you can see, the standard DIN rail case is available. On the bottom of the device, we have the password information printed. So whenever you access the device for the first time, just have a look at the password printed here because it will ask you for this password. We recently had some issues with some characters printed on this label because they were easily confused between 1, L, O, and 0. So we removed all these confusing characters now, and on the new production batch, you will have a better and clearer password. You can find the power requirements and the power details of the relays on this sticker right here. On the top, we have a series of LEDs that are showing you the operativity of the device when the inputs are closed and when the relays are activated. In this case, I'm powering my device using an external, using the network cable with a PoE switch. And I have also the possibility to use a power supply if I want to. On the front panel here, I have the reset buttons, the reset and the default buttons that are used to reset to default the device, to factory defaults. There are different usage for these two buttons, and all the information are published on the quick install guide that you have on help.barix.com, because there are many different types of applications that are triggered depending on how long you are keeping these buttons pressed. So here I have my contact closure connected to the device, and now let's go to have a look at the user interface, on the online user interface. Okay, I'm back on the PC. So as I said, the device is asking for password. In this case, I've already filled with my password. But first, before doing that, the device can be discovered with our discovery tool, which is a bit old-fashioned application, but is still very useful. So whenever you're not able to find an IP address of a Barix device in a network, in a local area network, you can always use the discovery tool. And you can see here, I have my device connected, and the IP address is this one. I can even open the web browser from the discovery tool itself. Now, I'm going to quit. So we are going to log in. And this is the Barionet 400 latest firmware version. Please be aware that this firmware version is the 2.17, is still not yet published. So the only difference that you have between the one that is published now and this one is this custom app tab that I will show you later on. For everything else, the firmware is exactly the same. I hope soon we will be able to release also this 2.17 firmware. So the first tab that prompts when you access Barionet 400 is the Wi-Fi tab. A bit useless in this case because Barionet 400 doesn't have Wi-Fi support. And the reason is because at the moment, as I said before, the firmwares are not aligned between all the devices. So the idea is to hide this tab when the firmware is run, for example, on a Barionet 400 that doesn't have a Wi-Fi chip. All the other tabs are instead working correctly. So we have the Ethernet tab. The device can be a DHCP client in your network, or you can set a static address. The status tab, where we can check the current firmware running. Okay, so we have the major version, the first three letters, and the latest version is the patch number. There is an ongoing discussion in order to understand if we should remove this patch number because maybe it's creating confusion among some customers, because the ones we publish online are only referring to the major version number. So the first three numbers here. If I click on check for updates, the device will contact, if it has internet connectivity, the device contacts the update server and it will check if there is a newer version in the server. In that case, you will see here an update is available and you can decide if you want to update or not your device. If I go into the SNMP tab, I can see the SNMP exposed settings, which we added because of the Informacast requirements. So we have the primary server. Here is where you set your, for example, your main server of Informacast, your redundant server, your secondary server. You can set the traps to be sent in an interval, so in X amount of seconds. If not, they will be sent once only when the contact closure is activated, for example. You can set and change the SNMP community password. This is also only available in the version 2.17 of the firmware. So if you are running version 2.16, this community password is not changeable and is private by default. In the version 2.17, we added this announcement, which should give you a bit more security by changing this password when you are connecting to SNMP devices together. And here I can activate the traps to be sent depending on the input that is closed. Under Synapse, I have my client activation button here. I can enable or disable the client. Now it's off. You shouldn't have to add any IP address of the server, but how Synapse is discovering automatically the endpoints. It is using DHCP option 72. If your DHCP server doesn't support that option, you will not be able to register automatically your devices. So, like in my home office, my DHCP server, which is in the router, is not supporting this. So I have to add my server IP address here. That's why we exposed this field. Later, I will show you how this will operate. So let's have a look at the custom app, new feature, really latest feature added in the firmware. Here, it's quite simple. You write your own scripts, your own programs using your preferred text editor. Like in my case, I'm using Sublime Text. Then you save the file. So you can then select your file and you can add your file to the device from here. You can enter the application name and click on submit. Once the application is submitted, you have a list of already submitted application in here. And for each application, you have several options. You can decide if you want to run it at boot of the device and if you want to enable the log. You can add the execution command here. Well, you have to add the execution command. So in this case, being a Lua script, the command to run a Lua script is Lua, simple as that, and then the name of the program. You can add dependencies or remove dependencies depending on which dependencies your application requires. So if you require a library which is not yet installed on the device, you can add your dependency in here and the dependencies will be listed below here. Now, I'm not showing you this because this is exactly why the feature is not released yet. This is still under test, so that's why we are not releasing this yet. And the latest lines here are related to the status, so I can see if my application is running or if it's stopped, like in this case. Whenever I want to run my application, I click on run, if it's not already running because the run at boot is selected. If I enabled the log, I can open the log files and it will open a web page where I can see whatever the application printed in the program. After 5 minutes, the session will expire. So up here you have an expiration of the session and you have an idea of how many seconds are left. Now, let's have a brief look at the Lucy interface. So I clicked on Advanced from the Barionet user interface, and here I am accessing the Lucy user interface. As I said, this is a very complete interface that allows you a very fine tune of the device, of the network settings, of the network interfaces. You can watch system logs, what is going on in the device. These are messages printed from the kernel. We can check, we can administer the system entirely from here. We can schedule tasks using the built-in cron program. And we can, one of the most interesting part is this, we can backup or restore the current configuration, the current firmware. And we can flash a new firmware image here. Or you can go into the Barionet UI. This is a custom user interface we integrated in Lucy, where you can check, this is the one that we saw before, you can check the status of the relays. Now I'm going to activate my first relay. And let me switch to the camera. You see now the relay is activated on the device. Okay. Latest thing about the security here is where you can enable the HTTPS access to the web user interface. Now I'm going to log out and I'm going back into my Barionet interface. And we can start with the first example. So I want to trigger a Synapse notification from my Barionet. So I have already my Synapse server running on my virtual machine. This is the Synapse server. So when you access the server, this is how it looks like from the dashboard. And let me show you under configuration and IP devices, Here is where the Synapse server is listing all the endpoints, well, all the IP devices that are registered with it, being endpoints or activators devices. In this moment, you can see that I have an active device, which is my IP former, IP speaker. I can see the details by clicking on the device. My Barionet device is not yet active because I haven't activated the client to run. So I will switch on the application now and I will set the server address. 105. So I submit. And now the server is, the client is running and the server should have identified immediately my Barionet device. Indeed, I can see that now is active. And here, when the device is connected to the server, it announces its capabilities, as I said before. So you can see here the GPIO numbers, 4 input and 4 outputs. The 4 outputs are the 4 relays of the device. We can even double check that by going into endpoints. This is all automatically added when the device is registered with the server. So you can see here for each general purpose output for each relay, I have one single object created on the Synapse server. At the same time, I have my activators and I go under IP devices. Here I have my 4 general purpose inputs, which are the digital inputs of the Barionet 400. Now, the idea here is to have a notification created, and I'm going to show you how the settings of this notification are. So I am sending a stored audio type notification. That means that when I will close the input of the Barionet device, I will trigger a file from the Synapse server to be played on the IP speaker. This is the notification type. I have to select, of course, my triggers. So I already selected here the general purpose input 1 from the Barionet device, but I can select also other triggers if I want to, and if I have other triggers available. Like in this case, I have up to 4 because the device has 4 digital inputs. The message details is nothing but the audio files that you selected to be played. And last, you have to decide, okay, where you want to send this notification. Now, in my example, I am sending the notification to IP speaker, as you can see here. Oh, I'm sorry, but you were not on this screen. I'm very sorry. IP speaker here, and you have all the outputs, the relay outputs of Barionet as well. So when I send the notification from Synapse, you can see the 4 relays activating on the device. Okay, now this is already saved and sent, so the device is ready to go. Now I'm going on the dashboard here. Let me check the volume of my IP speaker. I'm going to raise the volume. Oh, okay. I hope you can hear the background music. This is Barix Radio. Now, in my sources of IP speaker, you will see again here we have Synapse, and again the server address of Synapse. Barix Radio has priority 5, so the lowest priority. We will see in detail IP speaker, IP former in tomorrow's session. So let's go forward and let's try to close. Let's try to close the input 1, and you will hear the notification played from the ceiling speaker. And you saw as well the 4 relays activating as I configured in the Synapse server, in the Synapse platform. So this was all about Synapse. Now, let's go and disable the client. And now I want to show you, okay, let me also turn down the background music here. Good. So what I want to show you now is how I made a Lua script that sends a message on over the UDP interface to IP speaker and triggers the audio file that I loaded into IP speaker. So the application is already loaded here. First, I will give you the example and then I will show you the script. So IP speaker to play local files accepts a specific message to be received on a configured port. The port is configured under the sources here. So we can see here we have the port configure 8888. And on my Barionet, I selected my application. This is called IP speaker. Okay, I enabled the log. I click on save now because I'm not sure I've saved before. Now, when I run the application will start. And when I close the input, the message over UDP will be sent. So I'm going to run the application. Now let me switch back again to the camera. Oh, I have to keep the volume of IP speaker up. If not, we will not hear anything. Okay. So ready? And this was very nice file from a cow. I think it was perfect to stay in the Swiss topic. And now I will show you how I did it. So the script that is running on the device is exactly this one. Okay, let me just switch down the background music here again. So this is the example of an example of a Lua script that I made. Again, I am no programmer. I have not programming experience, but Lua is quite simple. It's similar to Python. It's also an interpreted language, so you can run your tests in your interpreter directly without having to compile the program. The script is mainly split into three parts. This is the main function used to send and is using the socket library built into the Barionet to send this string, which is exactly what IP speaker accepts. And it is sending to this IP address and this port number, as we see 8888, just like what IP speaker expects. The other function is a simple slip function to have a temporization of the iteration used in the main function that I'm using to start the application. So the last function I have here is a while loop, which is continuously checking for a change in the input of the Barionet. And when the input is equal to 1, the UDP sender function is called. So this function right here is called, and the message, this string, is sent to this socket. Easy as that. As you see, when the function is called under this if statement, we have a sleep of 7 seconds. So I'm not going to spam IP speaker too much. I wait 7 seconds once the notification is received, because I like it more in this way. And if the notification, if the value of the file is not equal to 1, so if the input is not closed, anyway, I'm adding a 1 second in between iterations. Now, you might be a much more experienced programmer than I am, so maybe you have even more suggestions to improve this script. Oh, at the same time, I am enabling the log to print that I sent the UDP command at this socket at this time. And we can check that if I look at the logs that are printed in here. So here you can see UDP command, file play. This is the string. It was sent at Wednesday, October 7th at this time. Good. This was another example. Okay, I still have 10 minutes. So the example about MQTT. So how I am using MQTT here, let me switch back to the camera. I have my phone that I want to show you. So this is MQTT Dash, is an application which is running an MQTT client. And I made a simple, very simple and basic example here to activate the relay. When I press the relay that you see on the screen on the top right corner, when I press the button on my phone, I will trigger the activation of the relay on my Barionet, passing through an MQTT broker. So the broker is this. Let me switch back. Is called Macchiato and is one of the many brokers online that allows you to have a free account and to use it for free, up to a limited number of topics that you have to create. So it's very simple to configure. It took me like 10 to 15 minutes to have my account created. I created 2 topics where the devices are subscribing to. So both my client on my phone and my Barionet are subscribing to, in this moment, to this topic right here. So whenever I press that button, the relay will be closed. Now, let me go back and start the application. And later I will show you again the code. Okay, all is good here. So I'm running the application. Go back to the camera. Now have a look at the top of the screen and have a look at the relay here. Okay. Because of the lightweight feature of the MQTT protocol, the message is sent very, very fast. I am not using the local area network connection. This is going through the broker in internet and then to the device, and is really, really fast. Now let's have a look at the code here. So go back here. This is the code I made. And essentially this code, I found it online. I will not hide this. And the only things I made in this code are to change these variables on top to suit my broker, to suit my username and password to access the broker, and the topic that I configured in the broker. And of course, I had to tell to the device what to do when the message is received. So this is the function. You can understand it also by reading it. So when the device receives the message from the other device, from the sending device, you have to do something. And in this case, I am executing this, which is also available on our quick install guide, and is one of the fastest way to activate the relay from the terminal of the Barionet. So I'm using the echo function. Echo1 will activate the relay and echo0 will deactivate the relay. So if the payload is equal to 1, because in this case, being a button, I have only 2 states available. One is 0 and the other one is 1, just like all the switches. So if the payload, so the content of the message received as a string from the client on the smartphone is equal to 1, then I am calling this. And this will activate my relay, just as we saw. Underneath here, I have simply the functions that are setting the login. So to log in into the broker and the port number that I configured. Now you saw the login was made using the TCP port 1883, but MQTT supports also the possibility to use the secure TLS and SSL connections over this port 3883 or over WebSocket using 8883. Now, another example is how can I use the USB? So I made this example where when I am closing the contact closure on my device, I log the timestamp into a file on a USB stick. If the file is not created, then it will create the file and it will print the timestamp in this file every time I close the input. So again, we will see, well, here there's nothing much, there is not much to see, but we will check the code and how easy it is to make that code. Okay, I'm going to run the application. Now it's running. Let me just check if I stopped. It's not because you can run multiple applications at the same time, but for sake of this video, I want to just use one at a time. So here I'm going to close the input, and that's it. Now, here on the logs, because I enabled the log, I can see that the time was printed on the USB stick. And this is the time that was printed. We can double check that by entering directly into the device. 2.68.8.103. This is the way I am accessing via SSH the device. I have to enter my password here. Okay. Now, the USB is mounted into a specific location. So this is the location where I'm mounting the USB. Now, if my script was successful, I should have a file called my time, I think, in here. And indeed, I have. So mytime.txt. And if I cat the content of mytime.txt, I can see that input 1 closed on Wednesday, October 7th, blah, 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 blah. And this file is created, is on the USB. So if I remove the USB, I can also take the file and bring it somewhere else. Or something that maybe was more useful to do here, I can program my application to send every end of the month this report of timestamps logged to a specific email. I was thinking to use it to keep track of the amount of time I'm working. So that was the idea. Now, okay, this is it. I'm going to stop this application. And now, since, okay, now let's try to write a script and to load it. I have 1 minute. Reto, do you think I can do this, or we should cut it here? You tell me as well.
No, it's okay. Go ahead.
Okay, it's gonna be quite fast. So I'm going to create a new file here. And we have, I want to use a function to activate the relay and switch it on and off intermittently every 5 seconds, for example. This is what I was planning to do. So let's just, first, I want to use the sleep function I already used. So the nice way to do that is to create, is to import the socket library to use the socket.sleep module within that library. So local, I'm going to create socket is equal to, oh, one of the coolest thing about Sublime Text is that when you save the file with the extension, it will give you syntax highlighting, so you can check that. It's easier to program in that way. So test.lua, I'm going to save this. And now we can see some colors here. Sorry, I made a mistake. So I'm going to require socket. And now let's try to do a while loop. So while true, do. I want to call my os.execute. This is a built-in library that allows you to call anything that you would call from the terminal directly. So any command that you are used to, like a cat, cd, or whatever you're doing in the terminal, you can do it in Lua also by typing os.execute. And in here, we are going to say echo 1. Now, I don't remember where the file of the relay is. So let me show you how to retrieve that information. You just head over to help.barix.com. We are going into the Barionet documentation, Barionet 400. We have quick install guide. Now let me find directly echo. Okay, here we have IO access from scripts or programs. So the device files can be found in the folder dev gpio is the main folder, and then we have the relay files under bio1 value, or bio2, bio3, bio4. These are the 4 relays. So let me just write this path in here. So root dev gpio, again back here, bio1 value, that's the file, and that's it. So I'm going to close my command here. Sorry, I missed the redirection. So I want to set this file to 1 because now is 0. Then I will place my sleep function here. So socket.sleep. It accepts the seconds as argument. So I'm going to say like 3 seconds. Then again, os.execute. And now I want to switch it off. So echo 0. And I'm going to just copy and paste the same thing here. Good. Again, I have to put another timer here to avoid deactivating and reactivating the script immediately when the loop finishes its iteration. So another 3 seconds. And I'm going to end the loop. So this should work. We can even add a print statement here, like print relay activated. So we are sure that the relay has been activated. Well, let me print it, sorry, before the sleep. Okay. So I'm going to activate the relay. I'm going to print something in the logs and in the terminal if I'm running this directly from the terminal. And then I am waiting 3 seconds, close the relay again, and wait other 3 seconds and redo the iteration until I don't stop the application. So this should work. Let me save this. Now let's go back to our Barionet. So I'm going in the configuration. Well, I am now using this new tab to load the scripts, but you can also do that from any like cp command from your PC directly, or secure copy if you want. Now we are doing it like this. So I'm going into my desktop, Barionet scripts. This is test.lua. Open. I'm going to call the application test, and I submit the application. Now here I can see it's already added, and I enable the log. The command to run the application is lua test.lua, and I save. Okay, now if I run my application, you can see the relay is going on and off continuously. Every 3 seconds. This was a very fast and simple example. And we can see also, well, in the logs here on the web, you can see only the latest log that was printed. You don't see it sequentially. There is surely a way on how to program the device to do that, but yet I'm not that far. So please bear with us. And yes, this was pretty much it. If you have any question, or maybe, I don't know, if Johannes wants to say something more about his farm, his technologies used in there, could be very nice. I don't know if we have time for it.
Well, I'm fighting, of course, with what? With programming Barionets for energy management. So that's why what I'm doing on the side here. Yes, you see my background picture. And maybe it's static, of course. It was in the morning where my battery, which is up here in the corner, wasn't really charged there. So this is maybe a typical use case which customers may demand from us for solar charging battery, whatever. I mean, you have learned in this training that the Barionet is very versatile. It can be programmed with many features. It has interfaces as well. And in the general market, I mean, one of the big sensor interfaces, of course, is contact closure. One of the biggest sensor interfaces is 4 to 20 milliamps. And if you look at the spec sheet of the Barionet, it doesn't talk about 4 to 20 milliamps. It just talks about 0 to 10 volts. So one of the things I would like to give you on the way here is if you have 4 to 20 milliampere sensors, they work on the Barionet very, very easily. I just grab one here from a bag. This, I have to hold it in front of myself so you can see it. This is a tank level sensor. And me, dump, not reading the Chinese instructions for it, I tried to hang it on top of the tank that it looks down and can tell me how much water is in there. Doesn't work. It needs to be dropped into the tank, and then it will measure the water level above it. So what does it have as an interface? It has, maybe you can see it or maybe not, just 2 wires. It's a 4 to 20 milliampere sensor. So that's one of those little jobs to connect one of those to a Barionet. Actually, it's trivial. You just need 1 resistor, and you can use a 12-volt power supply basically, and a resistor to make that a sensor which works perfectly on the Barionet's analog input. That's what I did. And if you look at my back there, you will find somewhere, which one is it? One of those curves will give you the tank level of my water system. The other ones give you pressure. The same thing. A water pressure sensor 4 to 20 milliamperes is very easy to get, very cheap. And if you put them to your system, they just have 2 wires. So with these 2 wires and 1 resistor, you connect them to the Barionet. And Barionet 1000 at least has 4 analog inputs. They are all capable of measuring up to 15 volts. And with a resistor, as I said, 4 to 20 milliamperes is trivial. If you want to know more about that, we can make an application now. So sensors for water, pressure, and for tank level is easy to interface. Then you have analog values. So what do you do with them? Well, you want to probably monitor them, but the one thing a lot of people want to do is to graph them. I want to see how my tank level develops. If I have a leak in my water system, because then the pressure will go down and the pumps go on all the time. So that's what you see down here in this corner. There, yeah, that's what happens there. For that, as I said, 4 to 20 milliampere is the interface. So let's consider that done. Something else I want to know is about my power needs, right? So I need a so-called current sensor. This one is an intelligent current sensor, 3-phase. In Europe, we have 3 phases. In the US, you have split phases eventually. So you will need something which measures the current going in and eventually out from your installation, and provide that information to the Barionet. This thing has a Modbus interface here, a Modbus RS-45. You may have noticed that most of the Barionet products don't have a Modbus interface anymore, but to the rescue comes something like a $5 stick, plugs into USB, gives you RS-45. And we have Lua examples on how to read registers and write registers into Modbus devices. This is easy to do, and you can use that with IO12, with X8, R6, and that other stuff, but also, of course, with these nice energy sensors. And I know, just get off and put that up in your face also. This is the heavy stuff to control. If you can see that, that's a big box, right? And that's a frequency drive for motors. For 7 kilowatt pumps. So if you get into optimization, or if your customers do that, and you want to control your pumps that they don't jump on with 7 kilowatts, pull down your grid, and then switch off, basically producing the same amount of problems mechanically for the pipes, and for that you need something to control the power usage and the speed. Of course, these variable frequency drives use Modbus RTU, yeah, RS-45 interface. So in my pump house, I have multiple pumps which have now these VFDs to be installed. I have the sensors for the tanks. I have the pressure sensors. So I can make a very gentle and long-lasting installation. I mean, the Barionet is paid within probably a year, just by reducing the mechanical load on the pumps, that they don't switch on and off like crazy. And also because I try to be grid independent, which a lot of our customers may have these applications in control and IoT. You want to use batteries, but ask my batteries what they say if a pump jumps on with 5 kilowatts need in an instance. The battery needs to have time to adjust, or the inverter has time to adjust to the ramp. So the VFD will also be used to basically slowly increase the need of energy for the pump. And the most important one is, if I just open a little, I take a shower, I don't need that much water, like if it's burning and there's a fire in the back, like in California. I mean, we have that in Portugal too. And I need the big hoses for the big water power to basically get all water out. If I need that, I need full power. For my shower, I don't need full power. So in that case, I maybe need only 10% or 20% of the pump capacity. A normal system, like everybody installs it to you, will have the water pressure sensor being a contact closure, activating the pump with the big relay. So bomb, the pump goes on. Then the pressure goes up quickly, bomb, the pump goes off. The whole building shakes. And then basically for like 90% of the time, the pump is off, and then bomb, the pump comes on again. So this makes a lot of wear on your pumps, a lot of wear off your building, on your pipes and everything. It is completely unnecessary. And you need a very high power rating to operate those pumps. So the intelligence in the Barionet can, of course, say how much really do I need of power, of pressure, by looking at how fast the pressure sinks, and then control the pumps to only use a fifth of their power, for example, constantly. So you have no changes in power load, so you don't blow your circuit breaker. And this is a typical, really good example. I mean, I tried to get my supplier of the pumps, I have two of them, to provide me a controller with VFD, and they wanted to charge me $2,000 for it, in addition, if I want the VFDs. So the VFDs are like 400, and the Barionet, you know how much it is? It just needs programming. So this is a very simple example of an application for a Barionet where it pays off within half a year to install it. Your energy needs are much more controlled, your pumps last longer, your pipes last longer, and you get the water pressure you need. And it's all done in Lua on simple scripting on the Barionet, using the 485 interface like this, yeah, and 4 to 20 milliampere sensors. But of course, it doesn't stop there. Now I also need to know how much power I use, and I want to know remotely if there's a problem. Let's assume one of my pipes break and my pumps run constantly. I can see that maybe from the variator, but I can also see it with my power monitoring. So I have very, very accurate power monitoring here. And if you look in my back, there's another graph. I mean, this is the battery up there, but I have one in the bottom somewhere where I measure the power. I think it's this one, of the pump house. So I can say, okay, there is one pump with 1.5 kilowatts. There's one pump with 5 kilowatts, and I can see which pump goes on and which pump goes on at what time. And I can exactly calculate how much water I use, because I know how much goes through the pump, even without a meter. And I can graph all that. And now, I mean, I don't want to steal all the time, because I think we have to close very soon. But this graph in the back there, last thing on this, we all know Barionet may need some programming. It needs some experts like Davide, myself, yourselves, Giacomo, to program that in Lua. You may say, well, I want something very easy to drop and drop, whatever. There is stuff like Node-RED and very nice controllers where you can drag and drop. Are they really reliable? Do they run 24/7 for years without a reboot? I don't know. And we built the Barionet for exactly that. It uses 2 watts of power, so it's very power efficient. It's absolutely stable against all ESD, which we produce with pumps and these kind of things. And the way I would set up those things is rather get this program once correctly, then you know exactly what happens. You know why it happens, and there is no excuses like, oh, the software did something wrong. And to graph things in these days, I mean, let's jump back. You know Barionets, of course, which we have since 15 years to record data sent by audio and Barionet devices to the cloud. 15 years ago, we built that for free for our customers to play with. It even could do some graphics, some simple ones. In these days, server monitoring and everything happens with open source software. And what you see in the back there, my sophisticated dashboard with multiple screens and everything, is zero programming. This is running on a cloud server, which costs $2 per month. And the cloud server is maybe 5% used, so I could run many more of those. The way this works is that Barionet uses an HTTP call, a very, very simple method with JSON data, which Lua natively produces for you, pushes the data out to a database, which in my case is Victoria Metrics, which is very, very easy to use and install. And then you have the modern buzzword is Grafana, so that behind is a Grafana software, Grafana instance, which runs on the same server, which you can click and drop. You just basically click on it, say, I want data from this server. I want these and these and these data points. I want to graph them for 1 hour, for this, for that, with these colors, everything. This is zero programming. Every one of you within 10 minutes can make a Grafana dashboard. Everyone. So if we provide you with a simple Lua program for a Barionet, which would be configured to just have a destination URL to where to push the data and provide you with all the contact closure and analog values, within minutes, you could make graphs like I have here to monitor whatever you want. I don't think you need to do that all on the controller. You rather use the technology as it is out there. I mean, Grafana is fantastic. What we could think about is providing a virtual image for a server which has that all, but I guess you find that from other people. Victoria Metrics is one simple install script, and Grafana is one install script. You do it on a $2 server, $2 per month. You click 3 things together and you have your graphics. So I close a little bit here. Just to recap, you can put all those kind of sensors on a Barionet. We can do Modbus TCP, which SunSpec, which I use to talk to my solar panels. I can use MQTT, of course. With MQTT, I go for data from a battery management system. That all works on the same Barionet. I have 10 Lua programs there, collecting all that data together, taking decisions, controlling the batteries, charging them, discharging them, switching on my cars. I have electrical cars, so I load to the cars when they have excessive energy. I stop when I don't have sun. This is all fully managed by one Barionet with a little bit of Lua programming. Is it complicated to do? Yes and no. I think for a home user who wants to click some things together and then doesn't matter if it eventually crashes because it runs on a Raspberry, that's all fine. If you want to do a professional install like we did with Singapore Power Grid, where we have like 10,000 devices controlling the security and temperatures and everything of the power substations, no. You don't want something 3 clicks and maybe it works. You want something 100% reliable. And this is our best reference for Barionet. We have since, I think, 10 years, about 10,000 units in field there. And they replaced already the first 2,000 or 3,000 with new ones, with IPv6 for the Barionet 1000 for exactly that reason, because there's 0 defects. That stuff always works in humidity in Singapore. It works without any problems. And I can highly recommend professional use. Take the Barionet with its automation interfaces. We are here to help you on the projects. We have fun doing those. And last but not least, we can even add modems. If you don't have Wi-Fi or networks, you can add a modem to the outside of the Barionet to use 4G to get that data out. This is our knowledge. We are here for you to help you on these projects.